Možno.
Tu integral a ten integrátor píše na začiatok, vieš, to prišlo divne. Oh,
Hello?
live. So, do we have speaker ready?
To posunieme.
Okay, in the meantime, welcome to our last session of the Java user group this year. Today we have Marian Varga speaking about Overlook API details, which I'm personally very curious about. So help yourself to food and drink and enjoy. Marian, floor is yours.
Thank you. So indeed, my name is Marian, and I love to integrate, as you can see, which means at some point I realized that most of my life I like to connect stuff together, connect devices, later software, pieces of software together, and make them work together. And actually, recently it got to the point, one more prop that I forgot to take out, is that I wrote a book about that. The book is here. The title of the book is Mastering RESTful Web Services with Java. It was published this summer. And basically I have a gift for you. Here's a QR code and URL lovetointegrate.com. If you register there, I will make a raffle at the end of my talk, and one of you will win this book for free. I have some spare copies, so in case you want to buy a discounted copy, you can as well. But everyone will be registered to my mailing list, where I send updates, whatever I meet in my daily work, and whatever I think is relevant to integration and connecting not just systems, but also connecting people that need to work together on software projects. I like to share this. So even, of course, book once it's printed, you cannot update it so easily. So that's why I also have other channels where when I produce some content. Now, why am I doing this actually? Because I've seen that many teams and many individuals don't pay enough attention to how APIs are designed and implemented. And that's unfortunate, because once an API is in use, it's not easy to make even small changes to it, because it's hard to predict what will happen to the consumers of that API. And of course, some large refactoring is very hard. So to avoid mistakes, we need to think a little bit more, and mastering just some implementation language like Java or some other one doesn't mean automatically you have the skills needed to create good APIs that will last and that will make your life nice and not terrible. And now my first question to you, do you have an experience that you ran into a serious problem because of some API that you or your team had to develop? Okay, at least one brave man. And the second question, did you have a problem with some third-party API that you had to use? Of course, that's always more people. It's always the other ones who make mistakes. So okay, if they are not here, just pass my knowledge from this talk to those other guys so that they improve, right? Okay, let's start. If I find my pointer again. Okay, here it is. First, we want to be stylish. We want to choose our style. We want to be consistent. We want to know what we are actually doing. And we have some options. Firstly, I am a programmer, and I think most of you are programmers. Of course, programming is or coding is not the only thing I do at work, but it still is a part of my job, and I enjoy doing it. And what the programmer usually actually wants is to invoke some method or call some procedure. The only problem is that procedure or method runs in a separate process on a remote machine. And now what to do? We have so what we really want is a remote procedure call, and we have great technologies for that actually. For example, gRPC. Who uses some gRPC or some other RPC? Who has experience with SOAP? Because actually SOAP is also a RPC style of communication. Maybe it's not such very, very fancy today, but it has some advantages. It has its good sides. So, of course, with RPC, you have to have some control over the clients that consume your API, because they need to be able to use that technology that you've chosen. And sometimes versioning the API may not be like flawless, because it depends what the technology allows you to do and how to make it compatible. But of course, you also get a lot. For example, with gRPC, you get great efficient encoding. You don't have to think about how network protocols and stuff that you're not really interested in. Now, another style that you can choose is messaging. Messaging is actually very natural, very close to the real world. Right now, I'm sending some messages to you by speaking, and when it gets boring, then you'll start sending some messages to me that I should just stop and let you drink some beer or something. But that's the way it works in real life. The only problem again is to implement communication based on messaging is a little bit more complex, because it's inherently asynchronous, and so anything can happen in any time and in any order, and so it brings some complexity, and you need to have some message broker usually, so there's another thing to take care of. So, but it brings you loose coupling. You can get great scalability from such systems, of course, if they are designed well. And it's a kind of integration that's usually used within an organization. Another style that is quite popular. Okay, who uses some messaging? Didn't ask. Okay. Who uses JMS? Who uses Kafka? Yeah, that's quite popular. Now, GraphQL is also a style of API implementation, and as the name suggests, it contains a query language. So the biggest advantage of it is that you don't have to, you can use it to query or to access some data sources or resources without having to know exactly what elements, in what combinations you will need, and how to combine maybe different entities that may be stored in different places. So it looks like a very nice thing, but that also means if you have something that gives you flexibility, then of course that flexibility will be used. And now that can mean that your clients will have some sophisticated logic that will use this GraphQL. And if you have multiple clients, then it is probable that this logic will be then duplicated, and maybe it would be better to put it on the server side. So, and of course, if you don't know what you will need, doesn't that mean actually that you neglected something from your analysis, that you don't know what you're really trying to achieve? So, yeah. Now, who uses REST? Everyone. Okay. So that's why I wrote a book about REST, because it's so ubiquitous. It's a lingua franca of software nowadays. It's based on technologies that were developed for web, but they can be used for any application. And why I put REST after all these other styles? Because I wanted to stress that you shouldn't just go straight to something because it's what everyone else is using and what you know, because there may be other alternatives that may be more suited for your problem. Then, of course, REST is a good way to integrate in many situations, especially if you have a web client. And the basic idea, from my point of view, of REST is that the client should be stupid or easy or simple and universal, and this allows the server to evolve independently and without having much impact on the clients. That's the theory. Now we have in the REST principles, we have something called hypertext as the engine of application state, or for short DTOs. Who has ever implemented an API with DTOs? Okay, we have somebody. I tried it myself once or twice, but I must admit it didn't bring me as much joy as I expected from being like fully RESTful. The problem is with where DTOs works without problems is the web browser, because it's a software that can interpret HTML, and based on that it can offer you this feature that you only need to know one address, one URL where to start, and from there you can navigate to any resource that site offers, or even to other sites, and it works great. But for a generic application that's not a web browser, this might be a little bit complicated to have such a language or content type that would work and that would be generic enough. That's why I was very happy when I learned about Richardson maturity model. That's something that a guy wrote about REST, that basically there are some levels of maturity, and you don't need to fulfill all of them. You don't need to be totally RESTful, and you still can get benefits from the REST principles. And from my experience, I can say that for real-world APIs, usually this HTOS principle is skipped, and there's a way how you can kind of complement it or substitute it, because there is a way how you can specify what your API can do and how to both humans and machines in a rigorous way. And then we have like a standard way to document our APIs, and that currently most popular language for that is called OpenAPI. Formerly it was called Swagger. All right. Now we are going to create some API. We have two basic options. We can be code first or specification first. Code first means we implement something in some implementation language, and then we document what we expose so that our clients know what they can do with that. The other approach, the specification first approach, means we have some abstract specification of our API, and then we implement something that complies with that specification. I believe that the code first approach is actually quick and dirty, and I will explain. All of you must know object-oriented programming, and one of the principles of object-oriented programming is encapsulation, which means we deliberately divide parts of our class or object that are public and which are private. And why do we do that? Because we want to prevent that our class or our implementation is like unchangeable, because we don't know who will impact. So if we hide parts of our implementation as private parts, then we are free to change them, because the outer world can only access the public parts, the public interface. So if this is useful for a program that runs within one process, then it's even more useful for APIs that can be reachable from the whole world. So that's why I think going code first is good for some quick prototyping, but for long term it usually pays off to start with a clean specification. And I can show you some examples, some more details. For example, here we have an implementation of an API using Quarkus, and here we can see it is also a kind of a specification. It somehow specifies the structure of our API. We can see there's some path, some subpath, some HTTP method. We can see that there's some inputs, some outputs. But the problem with this is that this specification is scattered in multiple files, because something is here in this resource class, something is in the in those model classes, that like this product description input, and even that may not be enough. Yeah, when we want to have a complete open API document, we may need to add things that are then very far from Java code. We may want to include some examples, some other metadata. Sometimes it's doable within the implementation code or near to it. Sometimes we even need to do it totally separately, and then it's very easy to forget about this. And when we want to change something, we always have to think about, okay, what will happen with the, yeah, I forgot to say that usually we do this because we want to generate the open API document from our code. And now we have to, on the one hand, we try to do everything in Java. On the other hand, we need to think, what will happen if I make changes to my Java code? What will happen with the open API document that is generated from it? So you still need to understand it. And so in the end, you don't escape this. Of course, nothing is for free. So even if you go with the specification first approach, you need to have you need to master two basic elements: the language, which is in our case Open API, and the tools. So, for example, a great examples. Open API allows you to specify examples for your schemas, for your payloads that are valid, and that's great because it can help both humans and machines to see, to have a better view of what's valid for your endpoints. On the other hand, it's not guaranteed that the examples are in sync with your schemas. So it can happen that you add some required field to your schema and you forget to adjust your examples, and that's not good. Another thing, of course, you want to generate some code stubs from your Open API document. So you need to know what generators to choose. There are multiple implementations. For each of them, there are some configuration parameters that you can use to tailor them to what you want, what library you want to use for implementation, etc. But even with this choice and the configuration, the generated code will probably not be like perfect to what you would be able to do if you wrote it by hand. Of course, it can be also an advantage because sometimes people are too creative. And it can even happen that, for example, some features from your Open API document will not be reflected in the generated code. I've seen situations that, for example, things that should be required are not enforced, and then it can happen, especially when it's outgoing, when you're sending some messages somewhere, that you don't generate a valid output JSON, for example. I found a nice, when we are talking about tools, a nice library that can be used to explicitly validate your REST endpoints against the schemas defined in Open API. It's from Atlassian. So again, there's something you need to know so that you can work with it well. Now, we talk about schemas, about structures, but another important thing is the meaning of the data that you pass on your APIs. For example, let's say we have an endpoint called products, and looks okay, like a great textbook example, easy, simple. Now in a real world, API is usually some boundary between two teams to bounded context, to separated worlds, and everybody can understand it a little bit differently. Very long ago already somebody said that naming is one of the hardest things in software engineering. So naming something so that it's like unambiguous is very hard. And I think you should try to be as specific as possible, because somebody could say, okay, why am I missing some product in this list? And the other part says, yeah, because it's discontinued or it's not on stock. But how should I know it? Then so either try to put as specific names as possible, or add some clear description to your schemas or endpoints, so that you avoid some misunderstandings. Another thing about meaning is, of course, we people have some ways how we think, and we should try to help people to understand. There are some guidelines how you can structure your APIs. For example, that the APIs should be some tree structure, and it's not something that is required by REST, but it helps. It's like the naming. It's something that helps people to not get lost in your API world. And one of those guidelines is also that when you're creating a RESTful API, the name of the resource should be a noun. So this is correct. This is not correct, because this is a verb. Why is it so? Because in HTTP we already have a method, and that's a verb. And having two verbs in a sentence doesn't help achieve some clear meaning. So try to use nouns. Another thing related to meaning, or some subset, which is very generalizable, is time information. We have great libraries to handle time in Java, but sometimes we can be overwhelmed, and somebody can say, okay, I want offset datetime. Somebody says, I only use instant, and I only use local time, and whatever. And we should again think about the business domain, especially because the backend people who are mostly responsible for designing APIs, they try to make their situation as simple as possible. So it can be tempting to just say, okay, if I need to store some time, let's standardize it. I only want UTC because it's just one number. It's easy to sort. It's unambiguous. It's great. But in reality, if it's not a timestamp that's generated by a machine, but it's some time that is entered by a human, that human usually lives in some time zone, and they understand time in their time zone. So if you drop that information, then if you have to display that information again, you will have to guess the time zone, and that can lead to problems and confusion. Another example, you may say you only need a date. What's the date today? What's December 9th, you say? Well, it may not be true. It's December the 10th in New Zealand. So again, you need to think about the real situation, and sometimes even if you think that you only need date, you may still need the time and the time zone. So again, ask your business people and analysts. Now here we start a series of things related to reuse. Reuse is a great thing. Programmers like it. We don't want to duplicate. We want to abstract. But in APIs, many times it can lead us in the wrong direction. By the way, do you know this site, Pet Store? It's like an example API, REST API, that probably many people who learn how to design APIs may refer to. And I don't say it's bad, but you can always find things that can be improved. So for example, here we have a put endpoint with path/pet. And sometimes we even forget what an URL is. URL means Uniform Resource Locator, and as such it is a subset of Uniform Resource Identifier. That means our URL should identify the resource, and of course if we just say /pet, it doesn't identify it. And usually if we want to put the pet, we also want to get, and for get we usually have the ID in the URL. So now we have an inconsistency. We are accessing the same resource with two different URLs. Why is this so actually in this case? Because we can see the ID is here. So I think somebody was lazy, and they already had a schema including ID that can be used, for example, for get, or for get you actually don't need it, but you can use it for post. Or actually, even with post, you just need then you just need to return only the ID. So yeah, but basically, yeah, the idea is we want to just reuse one schema for multiple things, and it will make our life easier, but of course then it leads to some problems, some inconsistencies. And in general, like I said at the beginning, not thinking and just trying to do things quickly, that's the most common source of problems. Now, second trap, this is a very common pattern that when we have a post or put endpoint in REST, that the response is the same as the request. So we are just echoing, returning what we just stored in the database to the client. And most of the time I think it's useless. So we are just wasting our network bandwidth. Maybe we increase the response time. How can we be sure that the client actually needs the data? Some common argument for this is that there can be some additional processing in the server, and we want to return the final state of the resource. But again, who told you that the client needs it? And second, there can be some parallel operation that modifies the same resource, so the client will assume it has the current state of the resource, which may not be true. So the separation of responsibility principle says if you are writing, then have an operation for writing, and if somebody needs to read, you have the get method for that. And you probably don't know this code, but I know it very well because it's from my book. And it is a proof that nobody's perfect. So even in my book, it was not for reuse, but maybe just out of this custom. We I'm not the only author of the book, but okay, I cannot say that I'm not responsible. If we are editing product description, why do we need to return the whole product in the patch method? So yeah, think first, expose things in your API only when you know you need it. Now the third trap is, I think it's caused by the fact that actually creating an API with modern framework is very easy. You just write some class, drop some fields in it, and tada, you have a working API that can be accessed from outside. But that's actually dangerous, especially if your approach to designing such a class is that you just take some list of fields that you have, for example, in your database or in some domain model, and copy over. Again, the same reason, because you should only expose what the client really needs. That's especially important if you have large resources that contain some embedded objects, maybe one-to-n relationships, some tree structures that can lead to the famous 1 + n problem, inefficient database queries. And actually, this is one of the rare situations where performance and security have the same goal. So of course, also for security, it's good that you expose only as much as needed. And then, of course, there's another hack that you can do, is that you have a JPA entity, and now you use it in your controller or REST resource directly. Who does it like this? No one? Basically, what you should do is you should have a separate class, separate model for your API. You shouldn't just use your database model. And I once had the opportunity to work with something like this, and then I saw this. So that's a really nice stack trace that contains both JSON and Hibernate SQL error in it. How is this possible? I didn't understand. Basically, it's because this Hibernate entity had some lazy loading, and it was the actual SQL was executed when JSON tried to deserialize my object, and that led to an error, and yeah, very messy. So again, don't do this. You can use, we have many nice libraries that can help you with mapping between the models. You should separate your inner sides of your application from your API related models. Now the fourth trap, you can say, okay, I'm already generating code from my OpenAPI specification. I already have my generator set up. So now it's very easy for me to also generate the client code on the same spot in the server project. Now I can share my jars with my SDK or client library that the clients can use, and they don't have to worry about HTTP or anything. Well, I don't think this is a good idea, because what we usually do with APIs is we want to decouple things. And now we are bringing the coupling again, because we are forcing the clients to use a particular library, a particular version of the library that may clash with what they are using in some other place. And of course, there can be even clients that use a completely different language. So what you should be doing really is to share your open API document. That's what it is meant for, and your client should have the freedom to implement the invocation as it suits them. Another idea that you may have is to reuse on this open API schema level, because you may have some structures that are repeated across multiple APIs. Again, it may not be as a great idea as it seems from the start, especially if that part that you want to reuse is not really stable. Because if it changes, then you have multiple versions that have dependencies in different places, and it's really hard to manage that. So sometimes duplication is better than too much reuse. One case where it's very common that you want to reuse something is for reporting errors. And again, you don't need to reinvent the wheel. There's already a standard for that, but it's called problem details. And some frameworks, like for example Spring, already have a class for that. So you just use what's already standard, and you don't need to have 3 different standards for reporting errors. Now, even though we want our APIs to last, it is inevitable that sometimes something needs to be changed, and it may not be compatible. So we need to have multiple versions of our API. Now, some people approach this just by putting some v1, like version 1 somewhere, and it's done. I think this is not enough, because basically versioning is a process, not a product. And you may know that managing a process it may be quite difficult. I've seen so many projects that claim they use Scrum, but what they really do is very far from the original Agile manifesto. And the same goes for this process of versioning an API. You need to have really clear rules. What is the situation, and how does it look like when you really move from v1 to v2? And it's also about the balance, because having many versions, maintaining multiple versions, the more you have, the more costly it becomes. It's really expensive. So and what's actually incompatible can be different from the textbook definition in a specific situation. Sometimes just fixing a bug can break your clients. And of course, you need to have some strategy. Putting, for example, this is very popular, putting version number at the beginning of the path. That will mean that now when you need to increment the version, do you really need to change the whole tree of your API resources? Usually you just need to change one of them. Now, how do you do that? Then there are some approaches using some headers, even the standard ones like accept. Again, there are people who say this is not right because if you define a content type, you should go to some world standard body and register your content type. I don't know, maybe it doesn't have to be so perfect. It's better to use something standard with your values than to define your completely separate header that nobody else knows. So yeah, there are different approaches, but you need to have a plan before it happens. And of course, you can try to avoid breaking changes, which is in general a good idea. But again, there's a balance, because then it can lead to really ugly schemas, like this one, for example. This is a beauty. What actually happens here is we have a schema inside the schema, and of course this is XML, and it needs to be escaped. It's not just very hard to read and process by your program, but it's very probable that this inner schema will not be documented anywhere, and even if it is documented, some things may not be true. For example, this encoding will probably not be true because it's already embedded in something. So what does this indicate? Again, this usually happens when there's a problem with the business analysis. You don't really know what you will need to pass, so you create something generic like this, and you say, okay, now I'm done. Yeah, I will never need to change this schema. But that's not really true, because as I said, this schema says nothing. And something similar is that you can define something like a key value list. So you can put any data there. Again, this is very generic, but when a key changes on one side and not on the other side, the integration will break, but it will be hard to detect. So sometimes it's better to make problems explicit and not try to hide them, and give some feedback. So maybe it's easier to it may be better to try your best to model the business domain using the schema, and if it doesn't fit, then of course you will need to evolve. You need to extend or evolve the schema, but at least it will give some feedback, and you will see it more clearly what happened, comparing to such generic and structures that say nothing. And of course, JSON is a very popular format for sending data. If you have a collection as input or output to your endpoint, the natural choice would be to use an array, but many times it pays off to add just a little bit overhead and wrap it in an object, because it can happen that you will need to add some metadata at the top level, and with an object you can do it. Now, how to implement our APIs? There are many great frameworks, runtimes, platforms, especially with Java, because Java is already 30 years old, and there are many options that we can use. How do we choose? Well, I'm not against innovation. Of course, we've seen many great things coming, but again, there should be some balance, and not some cool things sometimes leads to the point that we need to abandon them and switch to something else, and nobody wants to do that, or it's very risky to have to change the coding style of your application because you are switching from one framework to another one, or between some major versions of some framework. So how to prevent that? Well, there are, okay, I don't have like a definitive answer to that, but there are some trends that I found. One of them is that almost each framework that I've seen has at least two options. One is called imperative and the other one is called reactive. There were years when reactive programming was very popular. Everybody started using some reactive streams and pipelines, and every request went through I don't know how many threads. It looked very cool, but it means complexity. If you have to work with multiple threads, the thread stack traces only show you some fragment of what really happened, not the whole thing, and there are other problems. And so that's I don't say reactive is bad, but you need to think if you really need it. And actually, when working with APIs, a very common thing common reason why reactive was selected is that there's a lot of blocking operations, because there's network communication, and network communication can take thousands or even more longer time than just in-memory processing. So your threads are blocked and they wait for some networking operation. So that was the idea. Let's start using the thread for something else. But now with modern Java, we don't have to do that. We don't have to be reactive just because of this. You may have heard about virtual threads. So this allows us to use the imperative style, which puts much less cognitive load on the developers, and the platform threads will be used efficiently. Now, maybe again a little bit of a survey. Who uses Java 21 in production? Okay, not bad. So in Java 21 we already have virtual threads. Just there's one small thing that there's so-called thread pinning when there's a synchronized block. It's a rather old construct, but it may be used by some libraries that you use, and this means that such a thread cannot be reused for some other work. This problem was fixed in Java 24, so I encourage you to start trying. Yeah, okay, most people try to use the versions that have the long-term support, so now we have Java 25, so that's a good reason to persuade your managers to switch to Java 25 maybe. And so that's one thing, reactive versus virtual threads. Then another trend that I've seen is that the coding style shifts a little bit from annotations to something that uses more the functional programming style, DSLs with some tree-like structures that might have some advantages again. For example, in Kotlin if you use Kotlin, which is very compatible with Java, it has very, very strong support for such things. But again, maybe it's a good idea to think, do I really need it? Do I really want to depend on this particular framework just because it has the cool way of writing things? The other thing that we've seen is, for example, why Spring is so popular, because at some long time ago we had the Java Enterprise Edition, which wasn't very nice to use at the beginning, and then many people started using Spring as a layer on top of Java Enterprise Edition. Meanwhile, Java Enterprise Edition evolved. Now it's called Jakarta EE, and it's really different from what we had back then. And what we can really do, if we have some old application that still uses Java EE and somebody says let's switch to Spring Boot, maybe we don't need that extra layer and we can just stick to Jakarta EE, and then we have the advantage of having the freedom of using something that is standard, and we can choose some application server like Glassfish, Payara, or we can use a runtime like Quarkus or Helidon, and everything uses the same standard. Another thing is you should be careful, even if you choose a framework like that supports things like Jakarta EE or microprofile. Microprofile is overlapping with Jakarta EE, and it's also very good matching standard for microservices and for integration heavy applications. Then you need to make this deliberate choice that you really want to stick to the standard stuff, like I had here actually in that example. Yeah, so here we have these annotate. No, this is Spring. Sorry, this one. So when I was new to Quarkus, I started writing an example application using some guide, and it worked great. Just what I didn't realize is that I started using REST Easy implementation, and then when I wanted to switch to Helidon, it didn't work. So then I realized I really need to make sure that I use these Jakarta annotations, and then it's much more universal. So that's another thing to pay attention to.
Can I ask?
Yeah?
How hard is to configure your framework to use these vendor agnostic annotations? Like if I want to use this Java standard annotation, for example with Spring, what I need to do, like other than using just Spring annotation?
Well, with Spring, in theory, as I said, Spring is also just a layer on top of Jakarta EE. So in theory, you could also use just the Jakarta REST to expose your REST endpoints. But then it's like where do you draw the boundary? Because in Spring you already have the dependency injection, for example, the Spring style, and with Jakarta EE you can use CDI. So with Spring, I would say it's not so easy, because you will get into some conflicts of then you basically you shouldn't use Spring at all. Basically, you just use Jakarta EE and deploy to Tomcat, for example, and that's something else already, or some other container. So
there is no way to use Spring and use.
You can to some degree, but you will have to find a point where you stop, because before it gets too complicated or too awkward, like, you know. So that's why maybe 10 years ago switching from Java EE to Spring made sense, especially if you used to some old application server, some WebSphere that was hard to upgrade because there was some operations department that blocked it. Now I think maybe it's a good idea to at least consider some framework that uses the microprofile specification, like Helidon or Quarkus.
So if the layer is already written in a Spring, it has to be rewrite to use standard.
Yes, again,
it's not possible to use Spring with it.
That's already that lock-in. But for example, we have also Micronaut that has some compatibility. Yes.
I just want to add on this, because we are using Quarkus. In Quarkus, in particular, we actually have a compatibility layer with Spring, so you can actually deploy Spring Web, for instance. That is actually Quarkus Spring Web extension. Maybe you don't even know.
Okay,
so
I knew it was in Micronaut.
On Quarkus application, but it's not intended for long-term support. It's just like a transition period, and eventually we are expecting people to rewrite them to Jakarta.
Yeah, so there may be some tools like this. So yeah. But my point is, I understand that Spring is very popular and widespread. Even in our book we use Spring because we wanted to make it accessible to people. But what really matters are the principles, and if you already know the principles, then it's not shouldn't be too hard to use the Jakarta REST annotations instead of the Spring MVC or something like that, because the structure is basically the same. Okay, I'm too far. And the last line is coming back to what I was mentioning before. If you are doing the specification first approach, you can generate your stubs in any framework if you have a generator for it, and then you don't have to be so at least for the API layer, you don't have to be worried so much about this, because of course if there's an upgrade you can regenerate for a different implementation. That's one thing that you can do. And hexagonal architecture or ports and adapters architecture is also a great idea, which means basically that you have modules that are for your domain that are independent of any communication classes, and your APIs are in separate modules. You use interfaces. Yeah, you can look up what it is about, but basically this way you protect your core of your application from such things that are framework dependent or runtime dependent. We also use this structure in the book because we wanted to show the best practice. Now, of course, security. Can you tell me some favorite security hole in an API? Anything that you think is common? Okay, well, I would say check your inputs. That's something that's really generic. And for web services, of course, we have a resource that's called OWASP Top 10. That's a list of attacks on web applications, and most of them apply also to web services because they use the same technology. However, you need to also understand a little bit what these attacks are about. I also had this experience that a colleague came to me and asked, why do we have the CSRF protection turned off? We have it turned off also in production. And because CSRF is an attack based on sessions, that you have a browser where you have, for example, multiple tabs open, and you have some application authorized, logged in, for example, a banking application, and some other site tries to attack where to perform some operation that it shouldn't. If you use again the best practices, like for what I recommend for APIs, which means using stateless authentication, using for example JWT, which is the most common standard nowadays, then of course you don't have a session that can be misused. So that's why you can disable the CSRF protection. So again, we should pay attention to standards. It will make your life easier. Don't reinvent the wheel. Of course, if you use a standard, use a current version of things like TLS, because they can become vulnerable if they are too old. So yeah, I can't go into many details because security is really a big topic. Testing is another big topic, and one thing that I don't like is that managers they like to have numbers, and a great way to get numbers is to measure coverage percentage of your code. That's maybe good for that core, for your domain, but for your integration code, it's usually doesn't bring so much. It's just very annoying to write such tests, and they don't bring much because the errors that happen in the integration code are usually caused by things like authorization and deserialization, serialization errors, and other maybe some concurrency issues. So these things are not very suitable for the classical JUnit tests that use some Mockito or some basically that mock most of the real world. So my recommendation is to have in every project that is integration related to have a black box test that really starts your application as a whole and that tries to send real requests to it over the networking protocol that you use. Of course, it's not maybe trivial, but it has a lot of benefits. There are tools that can help you with that, like for example ResAssure is a library that you can use to generate requests and check the responses. Test containers is a great project that you can use to start your dependencies, like databases and message brokers in Docker automatically as part of your automated test. Then load tests are also very useful. You don't want to learn that something doesn't cope with the load that you have in production. You want to know before that, and to simulate it you need a good load generator. One of them is Gatling, and of course to help you with all these tools you can now use generative AI, and I must say I am a little bit of a AI skeptic, but I know that AI can be helpful, but you need to use it correctly, and to get good things from AI you need to provide it a good context. And now we are back to the things that like for example the specification first approach, because by having a solid specification that is consistent and has maybe good examples and is complete, you give a great context and guardrails to the generative AI to really create requests and tests that do what you want, and not maybe hallucinate less. Okay, and of course errors happen, and why is this incorrect? Any idea? 200. Yeah. Yeah. So this is actually what if you have experience with SOAP, SOAP tunnels everything through HTTP post, and most of the time you get it might not be always this, but it can maybe but it is more probable that you will always get 200, and of course when we are already using HTTP we should use it properly. 200 indicates to the client that it was okay, it can drop the data, and of course if it wasn't okay then data is lost. Now 400 and 500, again that's something that can be neglected, but if there's something wrong with the request and we return 500, then the client thinks, okay, it didn't work now, let's try again, and it will retry and bring our service down. So if we know that something is wrong with the request, we should return the 400 so that the client knows that it doesn't make sense to retry. Different situation happens when we have chains of calls, like services that are so-called gateways. That means A calls B, B calls C. Now when C returns 400, what does it mean? There can be two reasons for that. One is that already A sent something wrong, so B wasn't able to generate a valid request for C. In that case, actually the correct way would be the B should have validated the request from A. It shouldn't have called C at all. It should have returned 400 to A with some validation error. But if the request is valid from B's perspective, and C still returns a 400, it means something doesn't match, there's some bug, or so in that case it's actually B's fault, and it should return 500 to A. So the point is, if we have gateways are things that translate between two worlds. A has its view of the world, C has its view of the world, and if it translates the positive scenarios, it also has to translate the negative scenarios properly, because if we log into log and forward some error messages without really interpreting them correctly, then we can get some errors messages that doesn't make sense in the context that we see them, because of course in distributed systems the context is lost very quickly. So yeah, think about how to transform your error responses. And that's it. So if you still have questions, you can ask me, or you can register at my landing page, and you can contact me even later if you want.
Maybe I can have one question. So you said that your recommended way is to have a specification first, right? So then you would generate the clients, or like the backend entities, or DTOs, or mappers, or what would be your approach?
Yes. Usually the DTOs are the most important, but you can also generate the stubs for the resource or controller. What I usually like is to generate a Java interface and not a class. This way I'm forced to implement that interface with my code, and if anything changes in the specification and the generated code is incompatible, then I get automatically errors from the compiler. So that's a useful thing. And also, yeah, as I said, clients also can use the Open API to generate the client code, but it should be their responsibility and not the server's responsibility. So they are decoupled. Yeah, and actually one more question. Does anybody here have experience with async API? Yeah. So that's a similar standard to Open API, a newer one, but and that's the same idea, but for messaging interfaces. For example, Kafka or something else. And one thing that I found a little bit hard is that again, one thing is standard, the other thing is the tooling. And the tooling for async API is the official tooling is based on Node.js and JavaScript. So when I tried to generate Java from async API, some more complex stuff didn't generate as I expected. So that's again thing that you have to consider what your tooling can give you when you generate code. So yeah, or you can improve the generator, of course.
Have you already tried the Spring version API which they released in the 7th version? They released some like tooling to version your REST API. They have some annotations and some parameters, and it allows you to, like the situations which you described, when you need to upgrade only one endpoint to the next version, you can via annotations specify that that you still want to use older versions from other endpoints and so on. So have you seen?
I haven't tried the latest version, but I know that even in older versions you can use, for example, this versioning based on the accept header, because that's the content type. You can say which content type your method handles. Then you can have separate methods for two different versions if they have different content type. I haven't checked the latest version, but yeah, of course, newer versions of frameworks usually make things nicer. And the same goes for the standards, because now the latest version of OpenAPI is still, I think, 3.3, but there's OpenAPI 4 like pending, still not out. And one limitation of OpenAPI 3 that we saw was that when we wanted to use this versioning based on the accepts header, we weren't able to specify different request parameters. So for example, if your new version 2 uses some additional parameter, it wasn't supported by the OpenAPI schema. Then of course you need to do some workarounds, either put the additional arguments in both versions, or you can have separate OpenAPI documents. Okay, so yeah, both the frameworks and the standards evolve.
To help you, because like Spring 7 was released this November now. Like 2 weeks ago. Yeah, 2 weeks ago. So yeah, so like you still have time. So it's not like
yeah,
it's like very fresh.
a new thing. I haven't tried it myself, so I just ask your opinion maybe.
And I also think that there is no way how you can get around the issues that Marian was describing in the HTTP, in like normal, like API that you are exposing. So even if the library can support some kind of versioning, you are still limited by the same stuff if you want to expose your server to anybody else.
Yeah, so nothing is perfect. Maybe some funny stuff that I learned at one conference. I talked to a guy who implements the Jetty server, which is an HTTP server. I think the oldest one in Java and the quickest one. And he said even the HTTP specification of the HTTP protocol has some gaps. Not everything is specified. And if it's not clear, then what they do is they just use curl. And if it works with curl, then it's correct.
So, book time.
Thank you. Okay, now I should check.
Maria, maybe you wanted to do the book. I will stop the streaming, but you wanted to give up the book.
Yes, I will check.